Hey, good morning. My name is Arnie Kubiak, and I'm a SprinkCAD Technical Support Specialist. I've been with SprinkCAD for 10 years now. I originally started in fire protection in 1978, then joined Grinnell Tyco in 1980. I have worked for the company off and on ever since, including now that we are JCI. I have worked as a designer, a special hazards designer, programmer, and IT support specialist throughout the years. I am here today to demonstrate our fluid delivery time program to you and answer any questions you might have. First, I will demonstrate FDT as a standalone product, then a quick demonstration on importing a file from a SprinkCAD drawing. So this is our FDT program. I'm going to do a quick drawing for you and a time delivery calc. So let's get started. So the first thing I'm going to do is go to the overhead generator and build a system. Okay, so I'm going to pick the number of branch lines, the distance between the branch lines, the number of heads per branch line, the distance between the heads, branch line elevations, and you'll see all these are in feet, so I'm just putting in feet or decimal feet here. The head elevations, they'll be on the branch line, so the same. If you had a dropped head, then you could put a lower number and you'd have a head on a drop. Then we'll go to the next screen. Right now I'm a side fed system. If I wanted to, I can change this number of heads to the left and move it to wherever I want to for my system. So right now I'm a center fed system. I'm going to elevate my cross main, and that will be and then I have my choices. If I'm drawing a grid or a loop, I can use these others, but being a dry system, it's only going to be a center fed system. So where it says connecting main, that's near that'll be this point down here. And my offset, if you look at this little XYZ, is going to be in the negative direction of Y to come down here outside of the system. So I'm going to put in -5 feet. My first drop will be 2 feet down. And then my next one for my pipe direction, I'm going to go in a -X direction. And this time I'm going to go 50 feet. And then my next drop is going to be 21 feet. So I have my basic layout now. I am not going to use any of these because I'm not looping the system. So I'm just going to go next. I'm going to pick my sprinkler head. So all the sprinkler heads that are in our system are shown here. For this demonstration, I'll use an 11.2K head. The pipe scheduling right now, I have 2-inch schedule 10 branch lines, a 4-inch cross main, and a 6-inch feed main. I'm going to keep those. You can also use a pipe schedule. Right now I have ordinary light schedule in here. You can create your own within the program too to be used later on. And so then we'll go next again. For an FDT calc, I'm not going to do a hydraulic calculation, so I'm just going to insert my system at this time. Now this node right here is highlighted, and I'm going to bring up the properties box. You can either hit F2 or go to view properties. And right now it's a supply node because it's the last node I created for the system, but I need more piping before I get to my supply. So I'm going to come here for the type. And I'm going to change it just to a basic node right now. And over here, we have our controls. I can look at the system from different views. I'll go back to this one for now. These here, this will let me select pipes. So if I go like this, the pipes are selected. This one will let me select nodes. And this one lets me select both. And right now I want to select a node because I'm going to start back to here to add piping to my system. So now that I have that node selected, I'm going to go to modify, add pipes, and I'm going to do add new pipes. This brings up the add new pipe window. The node I have highlighted is shown as my start node. My pipe size is shown here. Right now it says underground. I am just going to make it a riser line. My material is still schedule 10, and my length, I'm going to start with a 1.5 foot piece for my dry pipe valve. And now I'm going to put in a 6-inch butterfly valve. And then I'm going to go down to the floor for my transition to my underground. And now I'm going to pick underground pipe. The default is my ductile iron 350. You can go through and see which other pipes you have. We do have C900 if you want to use the underground plastic. And as you know, when I pick these, you see the Z plus, Z minus, X minus, Y. That is based on this here. And so when I want to go down, I use the Z minus. When I want to go to the right, I use the Y, or to this direction, X will be in this direction. So right now I'm going to go down for my bearing. And then I am going to turn and go out the building 20 feet. And then I'll go 50 feet back to the side. I'm going to put a backflow in a vault, so I'm going to put in room for my backflow. And then we'll finish off the system and go back to our source. And now I have my basic system drawn, the system, and then my underground back to my source. This node is selected. This is going to become my source node. So back to my properties box. I'm going to change my node from a node to a supply. And now you see up here, we have device parameters. This is where you put in your water flow information. You can fill in the name, test date, location for this. I am not going to bother to do that. So at zero flow for my static pressure, I am going to put in 110 pounds. And then I'll post that. And for my residual, I'll do 2,500 at 95, post that. And now here's my supply curve. So now I have a supply. I need to add my valve. So I'm going to come here, use the pick pipe function. I'm going to select the 6-foot piece of pipe that I that I want to be my backflow preventer in a vault. So now I'm going to come here and here for my type, it says underground. I'm going to change that to BFP for backflow preventer. And it gives me a default backflow preventer. I can come in here and change it for this demonstration. I'll just leave the default. The device parameters, you'll see the curve for the pressure drop through the valve. And then I'm going to come here, and here's the piece I created for my butterfly valve. And again, I'm going to change the type from R line to valve. And this one, then I'm going to come in here and I am going to pick the what size? Oh, size 2, no wonder. I have made a mistake. These I want to be 6-inch pipe, so I'm going to select them. Oh, and come down here. Oh, let me do it one at a time. So this is now going to become 6-inch. This will be 6-inch. That is already 6-inch, as it should have been. And now for the valve, I'm going to have to change this back first to a pipe so I can change the size. It doesn't matter what I change it to. And I'm going to change it back to my valve. And now I have my BFVN butterfly valve. And then this will become my dry pipe valve, which is a DPV. In the DPV valves, we have dry pipe valves and deluge valves. For this dry systems to run an FDT calc, you have to pick one of the valves within the DPV section so you can put in the accelerator information and any pressure information you need for the valve. So I'm just going to use the DPV1 with accelerator. And then I'm going to open it up and set up my parameters for it. This particular valve has a differential trip ratio of 5.5, so I'm going to accept that. And I am going to add an optional accelerator. The accelerator that's in here is our older mechanical accelerator. If you have a different one, you can change these numbers to fit whichever accelerator you want. In this case, I am going to put it back to the default and just say okay. So now we have our supply, we have our dry pipe valve, and we have our system. And so I'm going to go to the top here, pick the nodes. The particular example I'm going to use requires 4 heads for the system I'm going to calc. So now that I have the 4 heads I want for to flow, I'm going to come over here and do create edit headset. You can also do it from the drop-down menu. And then I'm going to pick new. And if you don't see a new button here, if it's grayed out, that means you haven't selected any heads for the headset. So now that I'm at this point, I can tell it what I want for my head. So in this case, I'll do a commercial ordinary group 2. Actually, no, I think I'll do rack storage up to 25 feet. We'll make it a class 3. It's 40 seconds required, delivery time, 4 heads open. And then in this case, I am going to up the operating pressure to 25 PSI because it is a rack system with overhead sprinklers only. And I have all that information there. I pick the calculate button. Now our differential trip ratio is 5.5. We have 110 PSI static. To keep that valve closed, we need a minimum of 20 PSI. So just the 110 divided by 5.5. You can do the 20 and add 10% to keep the valve closed and put 22 in there. Often the valves have a minimum pressure that they require. In this case, this one requires 25 PSI minimum to hold the valve closed. And then I'm going to switch this to fluid delivery. NFPA only requires a fluid delivery. Calc, you do not have to get up to operating pressure. Our quell system does have you calc to operating pressure, or if the authority having jurisdiction wants you to go to operating pressure, that's always available to you here by putting on this radio button. So now that we're ready, I'm going to hit the run. And it tells us our calculations are completed. We pick OK. I'm going to go to the summary first. And this gives me my information. I have 25 pounds of air pressure. It did use actually the dry pipe valve opened with the clapper. I do not need an accelerator on this system. We are within our 40-second delivery time. In fact, we have the 32.9% safety factor for this system. So we're in good shape with this system. And then if you pick the analysis button, you will get the graphs to show what happens at each device. So you see our source, it goes in for almost 3 seconds. The valve opens, the water starts flowing from our source. The pressure dips a little bit and then goes back up. And then at the dry pipe valve, you see the valve open, the water start flowing, and then through all the other devices too. The H300, 289, 288, and 299, those are your heads. And so you see how long it took, a little over 26 seconds for the water to get to the heads. And so that's how the system works. There are limits here, and everything looks good. The only thing that is out of the limits is our maximum roughness. Now, when we got UL's approval for the system, they had brand new piping. What we're using here is standard Schedule 40 piping that has been aged a little bit to be a C factor of 120. So it shows it being out of the range of the UL listing here. We do have new pipe in the system to run to be within the UL listing. It makes a slight difference in your timing. So if you've put in a new system and you're running the FDT calc and you want it to be within the UL listing, then you would use the new Schedule 40 or Schedule 10 pipe with the proper C factor and roughness for the piping. Most AHJs don't seem to pay much attention to that, so most of the time I just run it with the standard Schedule 40, Schedule 10 piping. And now we ran it at 25 pounds, and it took just shy of 3 seconds to trip. So I'm going to up this to 35 pounds to see what the extra 10 pounds of pressure does to the system. We'll run it again. Back to the summary. And now the accelerator tripped it in just a slightly faster time, but not much of a difference. So it would be up to you on how you wanted to set up the system with air pressure. Sometimes with our storage systems, it actually helps even more when we put in the extra pressure to get the water to the open heads sooner. So I usually try to go in 5 or 10 pound increments with my air pressure until I find the best setting for the system I'm calculating at the time. Now, if we go to operating pressure, we'll run one more time. And now each head will have to get up to 25 pounds before the calculation is finished.
Arnie, we did have a quick question come through
Sure.
regarding this portion. It is, can the properties of the pipes be changed once the calcs have ran?
Yes.
Says, okay.
Okay, yes, I'll show you how to do that in a minute. So now you see it took almost 30 seconds to get up to operating pressure for the 4 heads, but we're still within our 40-second time limit. So this system is working and it is ready to go. Now, when you need to change any of the properties here, you always have to go back to the initial system to change any of the properties for the nodes or the piping. And that's because if you change it in the initial system, it'll change it for all the tabs under here. So it would change it for your hydraulics and your FDT calcs. So everything is done in the initial system. I can go in here and click on the schedule. All the schedule 10 pipe will be together. So I can click here, scroll down, which is pretty much most of the pipes, and then hold my shift key down. And as in any standard Windows program, that selects everything in between the two. Now I can come up here and bring up my properties window again. And so now all this pipe is schedule 10. There we go. And in my drop-down window, I can go into make it galvanized. And actually, the new is now called 10 tests. So I put it in there. And now we have the 10 test pipe. I'll go back and rerun the system.
Another quick question, Arnie. Did you
Yes.
close or open head?
Did I close or open head?
Yeah, that was the question. Is that, maybe I can ask Bernard to clarify that question.
Yeah, I mean, the 4 heads that are flowing will be the open heads. Everything else is closed according to the system.
Okay.
Okay, so as you see, it did not make much of a difference to the calculations at all, just very slightly faster to the operating time. And then once you're done, we have this little feature here where you can watch the system fill up with water. So I'm going to hit the play button. As you see the water compressing the air into the different branch lines. That's why higher air pressure sometimes make the system go faster, because there's less compression within the branch line. So it's pushed straight through to the open heads faster. And as you see, it's up to where it needs to be, but it keeps on running for an extra 10 seconds. And that's a setting within your system. It's good to leave that extra 10 seconds just to make sure everything stays up to operating pressure. Actually, another good thing with this is sometimes, depending on your source, and if you don't have a backflow, you'll watch the water push backwards towards the source because you have more pressure coming from your system pushing back here at first. Normally you're going to have some kind of backflow in the system. A backflow does actually work as a check valve and will keep the water from flowing backwards against it. So it's good to have a backflow in your system in your before your dry pipe valve. Any other questions? Or that's basically the FDT program.
There's no more in the chat, so if no one, if anyone does want to ask a question, they can unmute themselves, and if not, we will continue.
All right. Actually, I meant to have the drawing open first, and I forgot to do that this morning. FDT, when you have a pump, you have to make sure that you have your start pressure set properly. People have run their calcs and the pump never starts and they get a very bad delivery time. And it's because the pump hasn't started. The fire pump is usually set to start at about 15 pounds below the churn plus static pressure. So you want to make sure you put that in their pump data. I'll show you that with this drawing as it comes up. You can also pre-start a pump, and then you know it'll be running during your calculations.
While we wait for that to load, Arnie, there are a couple more questions. The first question is this a dry riser network?
Yes.
Okay. And then also another question came through. Are there any plans to update the devices shown in the program that were not available when the program first released? LP valves, DV5A, etc.
Not that I know of. You'll have the information, you'll be able to put them in yourself. We may get new valves in there, but often our part is the software. And a lot of the information, once we have the program out, is kind of up to the user to add. The information will be in the tech data sheets they can get from JCI or from any manufacturer for their valves. So you can add other manufacturers' valves to our system. A lot of people use the Victaulic NXT valve, and Victaulic has all the information for you if you want to use that in your FDT calc also.
Okay. A couple more. What about a fire pump and water tank?
A fire pump, actually, that's what this drawing that I thought I was bringing up was going to show.
Okay.
Let's try this again. Or am I just not seeing my own? Yeah.
We also have, so the valve accelerator will open by smoke detectors / third party, question mark.
Well, yeah, the accelerator, you're going to have to put in information for that if they are opened up by a smoke detector. And again, you will set that up as either a time delay on your accelerator. The accelerator is used to open up your deluge valve. And so you have to get the information on how much of a time delay from it seeing a fire to tripping the valve, and you put that in as your additional or your optional accelerator.
And then last, can you import a drawing from SprinkCAD?
Yes, that's what I'm doing here.
Okay.
Once I get the drawing up.
Okay, we'll jump into the next session then.
Okay. And this is still going to take a few minutes to open up.
Okay, another quick question popped up. It says, so we need a double knock to ensure there is no false discharge. Is that correct?
A double what?
A double knock to ensure there is no false discharge.
I'm not sure exactly what they're asking.
Okay. James, if you can just clarify that question, we can try to get you an answer. Another question, if it can be used in a deluge system.
Yes, it can be used in a deluge system. You can actually have up to 25 open heads. You can flow a small deluge system through and see how long it takes the water to get through each of the heads. It's not really listed for that, but it's available. Some people also use it to see how long water is going to get. It's going to take water to get to the valve in a manual standpipe system too. Again, it's not totally designed for that, but it does get used for that.
Okay, and real quick, double knock is saying it equals 2 inputs from 2 detectors in 2 different zones.
Oh, okay. Again, you will set that up into your, it doesn't really care that it's taking 2 inputs. You will just have to, it's only after it gets that input, how long there's going to be a delay from the second input to the time the valve trips. And that's what you put into your accelerator. This is just to tell you how long, once that valve is tripped, it's going to take the water to get to those open heads. Almost there. And we also do have single interlock pre-action systems in here. When you do a single interlock pre-action system, basically it's assuming the valve's going to open by a detector before the heads even open, so that has its own timing. All right, so I have a system here. Again, just a center fed, very long dry system. It's been calced. So hydraulically, it works now. We have our underground run to our pump house. I just have a ground tank feeding a pump. So there is basically no pressure coming from the tank. All the pressure is being supplied by the pump. So I'm going to run the hydraulic calculations here. Yep. As you see, you can't have the calculation running in the background. It has to be closed as a standalone before it will work with your SprinkCAD drawing. And this is the standard way you do a hydraulic calc on your SprinkCAD drawing.
Quick question, Arnie, what SprinkCAD version are you using?
This is, I think, the 0.25 version on this particular one. I have different versions for different AutoCADs on my drawing for supporting people. I was going to open up the 2016 version because that has our latest 0.29 version of the software on there. But this one is the previous version that we had available for people, and it's the one that more people actually have on their computers out in the field. All right, I have my calculation. Everything works. We're below the curve. Actually, let's do this so we can see the combined curve. So basically, we have a 11.5 safety factor. I'm going to do a save as. And I'm going to save this out to my hard drive. Bring up my calc program again. And then we'll open the file. All right. These heads are selected from my this remote area here. I'm going to select the heads for my fluid delivery calc. And then I'm going to, actually, I need to do a little adjusting to this first. The first thing I have to do is come to my source. And right now my source has almost no pressure. The system is going to have a jockey pump in it. And so I'm going to actually add the jockey pump to my source. So at zero flow, the jockey stop point is static plus churn. So in this case, that'll be 102 at zero. I'll post that. And then the jockey I happened to look at went up to 30 pounds. So we'll go down to 87 at 30. Oh, this is still here. Okay. So that's going to stay. And then 7. I did that again. Okay, then our flow is going to go down to 0 at 31. And then at 2500, we'll have 0 again. So now our jockey is included in there, so it's pressurizing our system. Our pump's all set up. The only thing I need to do now is make sure my dry pipe valve is set up the way I want it to be. So now we'll use a DV5 this time. Differential trip ratio in this case will be 0. I'm going to use my optional accelerator and say there's a 3-second delay between getting the information from the detection before the valve trips. And we'll say okay to that. We'll close out of here and then we'll create. Select our flowing heads and create our headset. And again, we'll tell it the hazard. This time I'll just do a commercial extra 2, 4 heads, 45 seconds. K factor is 8. Pressure in this case will be 7 psi for the operating pressure. And then we go to calculate.
Arnie, a question came through. Why are you selecting 4 and not 1 head?
Actually, let me go back. I'll show you. The reason I'm selecting 4 is because the hazard I picked requires 4. Now, if I would have done a commercial ordinary group 2, there's 2 heads. If I'd go to a light hazard, there's 1 head.
Okay. And is there a minimum distance to locate the valve or accelerator from the pump outlet?
The dry pipe valve or the, I assume that's what he's talking about. Basically, that will kind of be set up. It's not really in the program, but you will have your, which I don't, or no, I did. I think I have a check valve and a butterfly valve after the pump, standard pump setup. Then you go through and feed your riser in the pump room most of the time. So you're always going to have, 15, 20 feet between the two anyway. So it's nothing I really worry about if it's drawn properly.
I guess that question also too, they're following up with the 4 heads. Is that for NFPA
Yes, this is
standards?
for
Okay.
NFPA standards.
And is it the same for FM?
Actually, I don't know what FM's requirements are for the fluid delivery time that's different than NFPA. I have not really gone into that. I am more software support. We do have our technical support people, our engineering department that answers more of those questions. Mine is more on how the program works than on meeting the standards completely.
Okay, that's all the questions at this point, Arnie.
All right. Now we have a deluge valve. Normally, we still do have some pressure in here just to make sure this system does not have any breaks in it. Although if it's an open system, there will be no pressure here. So if it's a closed system, you'd have supervisory air. If it's a deluge system, you'd have no air in the system. And then we're going to go ahead and run this calc. And I think I forgot to do what I told people earlier. I forgot to go to the pump and set the start pressure. As you see, my calculating time is way up there because there's very little pressure going into the system. And so if you see something like that, that's normally what the problem is, that you forgot to set the start for the fire pump. To speed this up, I'm going to shut it down and reopen it.
Another question,
Hmm.
the pipework will be pressurized from the pump outlet up to the valve, question mark.
Yes, that's why I put that jockey pump information into the supply, so it would pressurize the system before the pump started. All right. Yeah, if I had not put in that information into the supply, there would have been no pressure. I would have gotten an error message that the supply was not sufficient for a calc. And we have the reopen button, so I can just pick that in here once you've run a calc. And since I didn't save it like I would normally do before I ran the calc, I'm going to have to redo the information for the supply and the pump and the dry pipe valve.
Quicktime check, we have about 8 minutes left in the session.
Okay. Actually, I can do it this way without selecting it. And this is what I forgot to do the first time. So the pump switching pressure would be the 110 minus 15 would be 95, not 85. We'll put a 5-second time delay that would set up my pump now. And then the last thing was the dry pipe valve. Okay. And we'll run. That looks better. Oh, and if you run loop calculations, they take a long time because of the two-step calculations with the water compressing and trying to balance the loop. It more than doubles the time, but quadruples the time that you'll sit here watching the calco. So you'll be sitting sometimes for 15, 20 minutes before the calc will finish, but you still might be under the time required for your fluid delivery.
Couple questions have come in. If you didn't set the pump, that means it would not run?
Correct.
Okay.
It would never get the pressure it needed to finish the calc.
And how many loops are allowed?
Only one. NFPA does not allow gridded dry systems, so you can only have one loop in a dry system. And I think that one loop actually pertains to the wet and dry portion of the system. So if you have a loop in your dry system, you can't have a loop in your underground. So if you look at the bottom of the time calculation, you'll see a calculating time and a program execution time. The execution time is higher than it was for the previous one, but if you look at the calculating time, that's actually how long it's seeing for the water to get to the head. So we're still under the 45 seconds that this system requires. So again, if you have the loop, that program executing time will get even larger before you finish the calc, although the calculating time, you can watch it and see if you are still under your delivery time.
Oh, we have one more. How do you set the pump to start automatically?
Well, there's the pre-start, which will have the pump basically running as soon as you start the program. And then I told it the switching pressure, which is normally the churn plus static pressure that you're going to have out of your pump. And that's what your jockey pump's going to keep the system pressurized to. And then the jockey pump, or actually the fire pump, usually starts at 15 pounds below that combined churn and static pressure. So whatever that number is, you subtract 15 from it, and that's when your pump's going to start. If for some reason the particular pump set up different from the manufacturer, you use whatever they tell you the switching pressure for that pump will be. Well,
Okay.
this one may not go through.
One more question here.
Okay.
A pressurized manifold outlet with 4 valve sets accelerators for 4 different regions is not acceptable?
Could you repeat that?
Sure. They pose the question of if you have a pressurized manifold outlet with 4 valve sets slash accelerators for 4 different regions, that is not acceptable?
No, you'd have to do one at a time.
Okay. We are getting close to the limit, Arnie. If
Yeah,
if we aren't able to finish this calculation, if there's any last statements you want to make regarding the process that you just took everybody through, we can maybe just talk through it.
sure. Actually, something I put in here is when I made it up, obviously it's not going to trip in the time. We're almost at the 45 seconds there. Probably, no, that should have done it. I'm not sure why this one didn't trip. I think normally it would. When I actually tested it before, I didn't switch it to the DV5 valve. I left it to a dry pipe valve, and then it tripped quickly. Oh, there we go. It finally did. So we can go to the summary here. And see, it still only took 31 seconds to get up to the fluid delivery time. So we're still within our 45. There's just more calculating it had to do with the pump, and it was a little more complicated system than the one I drew directly into the program. So each complications will extend your your program running time, your calculating time, although your delivery time may not go up that much when you do it. So just be aware of that when you run these calcs, even if it seems like it's running a long time, keep your eye on the calculated time to see where you really stand. Any other questions?
Looks like we answered everything that had come through the chat thus far.
Okay.
So I think we probably are good at this point.
All right, good.
That will conclude today's webinar. Just a reminder, all the attendees will receive a recording of the session, and we will also provide contact information for our technical services group if you do come across any questions that you might have after you watch the re-recording. Thank you for attending. Oh, we got one last one. Hold on.
All right.
When I did FDT, I didn't set the pump, but still below 60 seconds because of VDS. How is it then?
Well, then if your pump never started, you had a sufficient supply from the city to get the water to the heads in time. So it wouldn't have been an actual case though, because the pump should have started somewhere in there, and you should have had a faster time overall once the pump started.
Okay, and yeah, I think he qualified that with the supply was a pump.
The supply was a pump by itself?
Yeah, that was his statement.
Oh, well, if you put it in as the supply, then of course you're going to have sufficient pressure for your system. The pump will be started if it's put in as a supply, so there is no pre-starting or putting in the pump information. It just looks at it as a water supply at that point.
Okay, great. Thanks, Arnie.
All right.
Okay, at this point, we'll end the recording. Thank you for attending. We hope you found it informative and look forward to seeing you again at future webinars. Thank you all and have a great day.
All right. Thank you very much.